guys, so if we have a look at the first example, I thought I'd fixed it, but I obviously had not fixed it. What we've got here is solve for theta if cos theta times cos 24 plus sine theta times sine 24 is equal to 0,715, and theta is an element of, and that should, say negative 90 to positive 90. Did think I fixed it. I obviously didn't, but there we go. So this equation we'll get to in a second. I just want to chat about this last little bit going on here. What this is a restriction on your domain. So essentially we're saying to you that we know that there's an infinite number of theta solutions, because remember, there's two solutions within the first 360 for any trig equation, because there's two quadrants which the ratio is positive and where it's negative. So there's two solutions just within the first 360. You can keep adding 360 or subtracting 360 as many times as you want. So there's actually an infinite number of solutions to any trig equation, which is why we have the general solution where it has the plus k times 360 or 180 or whatever. In this specific example, we have restricted the domain. So I'm saying to you, find your general solution, but then use it to tell me which solutions for theta fall only within the domain from negative 90 to 90 degrees inclusive. So when they give you stuff like this, and this is particularly important when it comes to trig functions, because trig functions also go on infinitely, we only give you a specific portion of the trig function. So we will have obviously restricted that domain. When we give you something like that, it's important to take note of what it means, that we're only looking at a set number of solutions within a specific domain. All right, so that's what we have here. We're looking at negative 90 to 90, and we want to solve this equation. We deal with this situation at the end. Okay, so only after we find our general solution will we deal with that, and we'll chat about it when we get there. Okay, so what we should notice firstly, straight off the bat, is that this cos theta plus cos theta times 24 times plus sine theta times 24 is a compound angle formula. It's a cos sine sine, so it's a cos compound angle formula. Remember, cos is if it's a plus, it's then a minus in your expansion and vice versa. So what this means is that this whole thing actually simplifies down to cos of theta minus 24 degrees, because that's a plus. In the bracket, we actually have a minus, right? So using the knowledge we have of compound angle formulas, we have been able to simplify the whole left-hand side. That's obviously still equal to 0,715. And now we're going to start with our actual general solution. Okay, so like I said, I'll try to write some steps on as we go along, because for some people it's really useful to have steps. The very first thing that we always want to do is we want to isolate our trig ratio. Okay, so what I mean by that is you want to isolate sine, cos, or tan and its angle. That angle can have multiple terms. Like this one has a theta and a negative 24. That's fine. What I mean by isolate the trig ratio is that if there was a 2 here, you would need to divide away the 2. If there was a +1, you would need to subtract 1 on both sides. Essentially, all we want is cos, sine, tan, and then its angle. That is isolating. Right, in this case, that's already isolated for me, so I can move straight onto my second step, which is finding my reference angle. Okay, it's apparently not keen there. And if you can hear doors banging, I do apologize. I've tried to figure out where it is. I've got no idea. Right, so when you work out your reference angle, remember you ignore the sign of your ratio. Ignore, yeah. The sign will become important in step number 3, where we decide what quadrants we're working with. Okay, so over here, I'm going to do my reference angle. Reference angle is when you use shift on your calculator. That doesn't look like shift, so let's try that again. So in this case, I'm going to say shift cos. And on my calculator, I'm going to get that cos -1, and I type in 0,715. In this case, the sign isn't super important because of the fact that it's a positive ratio, so it doesn't really matter. If it was negative, it would. where we do that. And through this, we get that our reference angle is 44,3568. Now, I think a lot of you would just round that off to 36. There's nothing wrong with that, but try and keep more decimals than days, just because this isn't our final answer, and we should only ever actually round off our final answer. We're not going to be too strict with that. I'm just saying, as a matter of like best practice, work with 3 or 4 decimals. You can round off at the end. Okay, so once we found our reference angle, we move on to the third step that says use the sign of your ratio to determine the quadrants. Right, and this is now where our cast diagram is really important to us. So we've got 4 quadrants. Cast diagram tells us where things are positive or negative. Once we've done that, we will apply our reduction formula according to the quadrant where appropriate. Okay, so what that means is now that I've got my reference angle for this question, I go back to the ratio. Now this cos ratio was positive, which means that I wanted to know on my Cartesian plane, where is cos positive? Cos is positive in quadrants 1 and quadrants 4. So that's step 3. I've decided which quadrants I'm in, quadrant 1 and quadrant 4 for cos. I should have left mine. I think I've left myself enough space, but we'll fix it if not. Now we start to apply our reduction formula. Now in quadrant 1, there is no reduction formula. It's just theta. Now what we do is we take the angle of my trig ratios. In this case, it was the theta minus 24 degrees. And we make it equal to whatever the reduction tells me to do. Because this is quadrant 1, it's just equal to my reference angle, 44,3568 degrees. I'm now working with angles, so I have to have that plus k times 360, where k is an integer. Now I solve. It's like any other equation, inverse operations. So I'm going to plus 24 on both sides. So theta is equal to 68,36 degrees plus k times 360. Yeah, I don't know what's happening. We'll fix it all in a second, where k is an integer. So I've got my first solution for my first quadrant. Now I'll move on to the second quadrant. Same thing, take the angle, attach to my trig ratio, theta minus 24 is equal to, I'm applying the reduction formula where necessary. Quadrant 4 is 360 minus my reference angle of 44,3568 degrees, plus that k times 360, etc., etc. And now again, I use my inverse operations. If you can do the 360 minus 44 and then plus 24 altogether, wonderful. I'm going to do it all together, and I get theta is equal to 339,64 degrees. Again, plus k times 360, where k is an element of the integer number system. Okay, these two things that we have just found, so this theta equals 68,36 and the theta equals 339,64, these are what we call our general solutions. Oftentimes, or sometimes, the question will say to you, determine the general solution. In this case, that wasn't the case. I had specific values I need to find. But just so that you know, if you're asked for the general solution, once you've essentially solved, you're done. That's the general solution. But this was not the case in this question. This question specifically asked me for my values of theta between negative 90 and 90. So now I need to actually go and deal with that. So we were told theta is an element of negative 90 to 90. And to do this, guys, we use our general solution. So what we do is we work with each of the answers I've gotten. So I've got 68,36. First decide, does that fall in your domain? It definitely does. So that's going to be part of my solution. And now you either keep adding or subtracting 360 until it starts to fall outside your domain. If I add 360 to this, it definitely falls outside my domain, so I'm done. If I subtract 360 from this, definitely falls outside my domain. It's definitely less than negative 90. I'm done. So I move on to my second solution now. 339 is already outside of my domain. So now I start adding and subtracting 360. Adding 360, it takes me to like 690 something. Definitely not. But if I subtract 360, so if I said 339,64 degrees minus 360, I'm going to get negative 20,36. And that's definitely within the negative 90 to 90 domain. And so what that means is that theta here is either equal to negative 20,36 or 68,36 degrees. You can also write this as theta is an element of, and then use curly brackets. This is actually mathematically more correct, but again, we're not like super strict about this. It's not what I wanted to do, but it's what I did. And so these are your two and only two solutions that fall within that specific domain from negative 90 to 90 included. Right, so once you've started applying your reduction formula, you then essentially, as your last step, is you start to solve your equation. Right, that's it. When you have a situation where your domain is restricted, you do need to do this additional step of finding the specific values that fall within that domain. But if I say just this general solution or just solve for and don't give you a domain, you don't have to. You just stop at the general solution, so what I've highlighted in blue, and you're done. All right, so let's take a screenshot. Remember, guys, if you've got questions, please ask. You can put it in the chat, you can raise your hand, you can unmute yourself, whatever you're more comfortable with. But please do ask, but you're going to try one by yourselves now. I also need to put on a light. It's gone very dark. Okay. Right, so this is the one I want you guys to try by yourselves, very similar to what we've done. Think about your compound angle formulae and go and solve for theta here. I haven't given you a restricted domain, so you just stop at the general solution. You don't have to go further and give me specific values in this case. But let's give this one a try, and again, ask questions if you're not too sure. Okay, guys, remember you should have two solutions. I'm going to give you 1 more minute and then I'm going to put up the answer. Okay, let's have a look. So very similar to what we already had. It's a situation whereby it's a cos compound angle formula where it's A minus B. So reference angle, remember, ignore your sign. So it is shift cos 1, which gives you 0. Now, no, I don't know what I was going to say, sorry. So that's the reference angle. Now we go back to the ratio, which was -1, and we decide based on the sign, what quadrant am I working in? It's negative, cos is negative in quadrant 2 and 3. So we apply the reductions appropriately. Quadrant 2 is 180 minus the reference angle. It's 180 minus 0 degrees. 180 minus 0 is obviously just 180. Math. Using inverse operations, you would have 180 plus 40, which is 220. Divide everything by 455 degrees. Sorry. For the second one, quadrant 3, it's 180 plus. 180 plus 0 is also still just 180. So you end up with exactly the same solution. So you get two solutions. It just so happens that they are identical. If they are identical like this situation, you can just write down one of them as your final answer. You don't have to give both. My advice, though, is just have both. If they end up being the same, then they end up being the same. It is what it is. But rather have both and then show your marks, then leave off one mistakenly and then lose marks. Alrighty. Hopefully I haven't made any other mistakes except for that silly inverse one. But essentially you're solving an equation as you always would. Okay, nothing super special, super stressful about that. Right, so take a screenshot and then we're going to have a look at another example. Alrighty. So if we have a look at example 2, we want to find the general solution of sine 2 alpha plus 2 sine alpha equals 0. Now, guys, what I want you to be mindful of here is the fact that 2 alpha and alpha are not the same angle. So you can't just add them together and say, oh, cool, I've got 3 sine 3 alpha. That's not how it works, unfortunately. What we want to try and do is get those angles the same. And the only way we can go from a double angle alpha to just alpha is using our double angle identities. So for sine, luckily, there's only one. Obviously, if there was cos, we've had this discussion before, but if it was a cos double angle, you would then need to look at the rest of your equation to determine which would be the most appropriate formula to use. All right. But like I said, in this case, nice and easy, it's a sine double angle. So we're going to change this to 2 sine alpha cos alpha. That's not how you spell cos. Cos alpha. plus 2 sine alpha is equal to 0. And what you'll often see happens once you've applied your identity or your formula, whatever it is you need to do, is like in this case, both of these terms now have a sign. And so what that means is you can factorize. Now, my highest common factor here is a 2 sine alpha, leaving me with a cos alpha. I can't spell cos tonight. Cos and I really aren't on the same page tonight. Cos alpha plus 1. And remember, because you factorize, what you've actually got there is a quadratic equation. Any quadratic equation, one side should be equal to 0, which in this case it was. And once you've done that, you make each of your factors equal 0. So we would have 2 sine alpha equals 0, and then we'll solve, which I'll do in a second. And then we've got cos alpha plus 1 is equal to 0, and then you solve. So what often happens when you factorize is that you're going to end up with 4 solutions because you have 2 brackets that create 2 equations, and each of those equations have 2 solutions. But you follow the same 5 steps as we had earlier. Okay, so I'm going to divide both sides by 2 in order to get rid of that coefficient, because remember my first step was to isolate my ratio, and so I've got that sine alpha is equal to 0. Reference angle, shift sine 0 is equal to 0. And again, it doesn't really matter which equation you start with. I'm just starting on the left. Doesn't really matter. So my reference angle is 0 degrees. Now 0 is a bit of a tricky one because it doesn't have a sign, but in situations like in trig and like nature of roots, when you're shifting a graph up or down, we work generally with 0 as a positive. So essentially, where assigned positive, it's quadrant 1 and 2. So quadrant 1 is then, silly of me, is then where alpha, that's the angle, is equal to just 0 plus k times 360, where k is an integer. Got that first solution. Our second solution is then in quadrant 2. Quadrant 2 is 180 minus. 180 minus 0 is still 180. So 180 plus k times 360. All right, if you don't agree with anything I'm doing, please just shout. Yeah, it's absolutely fine, but we're just following those same 5 steps that I wrote down earlier. For my second equation, again, remember, first step is to isolate that ratio. So cos alpha is equal to -1. We now find our reference angle by saying shift cos. Remember, you ignore the sign. So my reference angle here is 0 degrees. And then we go back to our ratio. Cos is negative. Cos is negative in quadrants 2 and in quadrants 3. In quadrant 2, we will have alpha is equal to 180 minus my reference angle, which is just 180, because 180 minus 0. 180 plus k times 360, k is an integer. And then in quadrant 3, this is where we've got 180 plus my reference angle, but again, 180 plus 0 is still 180. Okay, now again, you've got your 2 solutions for this trig equation. Now guys, what I want you to notice is that these 3 solutions are all identical. So if in the end you actually just said that alpha is equal to 0 plus k times 360, where k is an integer, and alpha is equal to 180 plus k times 360, where k is an element of the integer number system, that's obviously absolutely fine. Okay, all you're doing is just not repeating the same solution and giving me a concise answer here in terms of what is alpha actually equal to. Again, if you leave all 4 solutions, that's absolutely okay as well. We're going to mark it. Just understand that when you do have repeated solutions, it is fine to write it just once. But if you feel more comfortable, rather just write them all down. There's nothing wrong with having the same answer twice. We know that that happens. All right, so just bear in mind, sometimes you have to factorize. Sometimes it's highest common factor, difference of squares, trinomial, all of these things can apply. Okay, so take a screenshot, and then I'm going to get you to try one by yourself. That also deals with factorization. I will help you a little bit with this one, but you are going to try it by yourself. Okay. All right, so this is the one I'm wanting you guys to try for me. I'm going to help you out a little bit, because what you should see here is that you've got a 2 sine squared beta plus a sine beta equals 3. So imagine this algebraically as 2x squared plus x equals 3. What you have here is a trinomial or a quadratic expression, so we can factorize. I've said this to you before. If it helps you to think of this algebraically, so if it helps you, cool. If it helps you to think of it in terms of x's in order to factorize and then sub back your sine beta or whatever it is, do it. There's nothing wrong with that. Remember K method that we learned in grade 11. So if you are more comfortable with that, do it. Otherwise, essentially think of factorization. And I've kind of already told you which way to do it. But let's give this a try, and then we'll have a look at your answer. I just muted myself, I'm sorry. We will look at your answer in 4 or 5 minutes. Ask me questions as you go along. You can put answers in the chat as you go along, but let's give this a try. Do we need a bit more time, grade 12s? Just let me know if you do. No one's let me know. I'll give you 1 more minute and then I'll put up the answer. Okay, guys, let's have a look. All right, so exactly as I think Bongi and Kosi put an answer down in the chat. Thank you. So exactly that. We've got 2 solutions only this time. I'll explain why that's the case in a second. But both of those solutions are actually the same. And so if you only wrote 90 plus k times 360 once, that's absolutely fine. If you wrote it twice, also absolutely fine. It really doesn't matter. All right. But just quickly to go through these solutions. So I gave it away in that it's a trinomial, so you factorized it. If you want to imagine this, like I say, as the 2x squared plus x minus 3 equals 0, and then factorize from there, so you get 2x plus 3x minus 1 equals 0, and then replace your x's with the sine beta. That's fine. Help yourself through using K method or, you know, a substitution type method. Either way, we go and solve and we make each of them equal to 0. Now, for the first bracket of the 2 sine beta plus 3, also it would help if I put the correct sign here, you get sine beta equals negative 3 over 2. Now, the reason that gives you no solution is because sine, if you think of it in a triangle's opposite over hypotenuse, if you think of it on a Cartesian plane, it's y over r. In both cases here, h and r, you can't see that now, so let's make another attempt at that. In both cases, h and r are the longer sides. Remember, your hypotenuse is the longer side in a triangle, and thereby your radius is the longer side on the Cartesian plane. And because of that, because r or h will always be the biggest, it is not possible for you to have an improper fraction. Those biggest numbers are always in the denominator, so your fraction will always be a common fraction. Because it's not possible to get an improper fraction, it therefore is not possible for your ratio to be greater than 1 or less than negative 1. Now, this situation down here is true for both sine and cos. Okay, so both 1 or less than negative 1, you're going to get no solution, and that's because of just how the ratio is set up. Right, so that aside, the other solution would be your sine beta reference angle is positive, or sine is positive in quadrants 1 and 2, and you get your solution. All right, so hopefully not too tricky, but factorization, just bear in mind you do need to be able to do it with trig equations. Just waiting for you to take screenshots, and then we're going to have a look at our last example. Okay. So if we have a look at example 3, we have got cos squared x minus sine squared x is equal to 1. I can't remember why I made this do this one, but we're going to do this one apparently. Why did I want to do this one? Okay, anyways, we're doing this one. Cos squared x minus sine squared x equals a half. Okay, now the cos squared and the sine squared, we should sort of have it in the back of the mind, that it reminds us of some rule that we've learned somewhere. Now, please don't get this one confused with your square or your Pythagorean identity. That says sine squared plus cos squared is equal to 1. This situation here, if I could even underline, this situation here is your cos double angle. So what this actually reduces to is that cos of 2x is equal to a half, right? So we've used a compound angle situation where we went from the expanded compound angle down to a single term. Here we've got a double angle and we can essentially write it as such. So we always need to be thinking about, why is this familiar to me? Is it an identity? Is it one of my formulas? How can I apply it? Now, the reason I wanted to apply that in this case, because we've got two different ratios there. You've got a cos and you've got a sine. Yeah, that's the difference of squares, but remember that only works if I can make one side equal to 0. In this case, for me to make one side equal to 0, I would have cos squared minus sine squared minus a half. That throws the whole thing out of whack. So always look out for your formula that you know that you can then apply. Right, now that we've done that, our trig ratio is isolated. I don't really have to do anything there. And so the next thing that we need to go and do is find our reference angle. Ugh, technology. Right, we ignore the sign, so it's just shift cos a half. Remember, that is actually a special angle that we should know, but that's 60 degrees as our reference angle. So we've got our reference angle 60, and now we can start solving. The ratio of cos was positive. Cos is positive in quadrant 1 and in quadrant 4. So those are the two solutions I'm looking for here. And then I go and essentially solve. So remember, we take the angle, 2x is equal to, and apply a reduction. Quadrant 1, it's just the angle, so 60 plus k times 360. K is an element of integer. And in quadrant 4, it would be 2x is equal to 360 minus 60, because that is your reduction that applies in quadrant 4, plus k times 360. All right. So what I want you guys to do for me is just finish solving those two equations. What are your values for x that we get for your two general solutions here? Okay, I'm going to assume we're done. They weren't particularly tricky. So in our first one, what we are doing is we need to divide everything by 2. So that leaves me with x is equal to 30 plus, now please remember we have to divide this by 2 as well. So k times 180. For your second solution, you would have the 360 minus 60, which is then 2x is equal to 300 plus k times 360. And then again, you're dividing everything by 2. And so x is equal to, 150 plus k times 180. Right, now what I want you to take away from this is if I had restricted my domain, so if I'd said something here like x is an element of negative 180 to positive 180, for example, when you now go and find the specific solutions, you need to be now taking into account that you're adding 180 each time, not 360. So that's why right at the start, we always work out the general solution. If we then have to find specific values, we will use the general solution in order to do that. We cannot ignore the fact that that angle is a double angle. Remember, a double angle means that your graph, I never know how to say this in like proper words, but the cycle of the graph repeats faster. So what that means is a normal cos graph will look something like this, obviously straight line. Here, I hate technology tonight. It's not going to be my best in cos graph in the world, but it's okay. So a normal cos graph looks something like that, where your period is 1. So this would just be cos x. The cos 2x, everything happens twice as fast. So this trough happens twice as early. So now the trough is happening here. Your peak happens now earlier. It's not mathing tonight, and the drawing's not drawing nicely. Why is everything hating me? Okay, sorry. I'm going to draw it nicely now for you once things start working out for me. So like I say, your trough happens earlier, your x-intercept happens earlier, your peak happens earlier, and so everything actually happens twice as early. And so it's such a bad graph. And so there's 2 and 1. Okay, everything's just going wrong. Okay, everything's going wrong. I'm not going to fight with it because I'm just going to get frustrated. But a double angle means that your period has changed. Let's see if it'll work with me. The period has changed, and so the graph completes itself in half the time. I'm going to try again. Let's see what happens. No, it's not me at all. It would look something like that. And then it disappears. So, you know, whatever. But that's essentially what a double angle means. And so you just be mindful of it. I'm not leaving the graph situation. I tried to be fancy by explaining it with a graph and it hated me. So we're moving on. But that's what a double angle means. And so that is why we have k times 180. Because remember, if you think back to your trig functions, that coefficient to your angle, if it's cos px, that changes your period. It either makes the graph happen much faster or stretches the graph out and the cycle occurs much slower. So it's just something that we need to bear in mind when we now go and find the different solutions across your Cartesian plane. Okay, if you'd like to take a screenshot, take a screenshot. This was absolute chaos in terms of the graphs. I do apologize. Like I said, try to be fancy, shouldn't have tried to be fancy, should have just stuck with the good old words. Right, guys, it is Wednesday, so please just remember that it's quiz day. Your quiz will be on Google Classroom in the next 3 minutes. Also, just remember we're starting with geometry on Monday. I won't be there, unfortunately, because I've got parent meetings, but you are in very capable hands. There is still a lesson, so you will still have class on Monday just with the substitute teacher, but she's wonderful. She's probably better than me, although it's not I don't know, that's not saying much. But yes, you do still have class on Monday. You will be circle geometry. Just